In this problem, we're asking about the integral from negative infinity to positive infinity of e to the negative x. So graphically, that looks something like this, and we can see that the graph continues on without bound. To the right, it's approaching the x-axis, but not actually going to ever get there per se. And on the left, it is just increasing as x gets larger. And so, in this case, we're really going to break this up into two improper integrals, and we can choose whatever point we want to break this up at. We can choose whatever we want. I'm going to choose x equals 0. And so I'm going to consider two things. One, the integral from negative infinity to 0 of e to the negative x dx plus the integral from 0 to infinity of e to the negative x dx. And in order to deal with this, I will need to basically take the limit of both of these expressions. So this will be the limit as a goes to negative infinity of the integral from a to 0 of e to the negative x dx plus the limit as b goes to infinity of the integral from 0 to b of e to the negative x dx. And in both these cases, these are nice as far as integrals go. The integral of e to the negative x will be just negative e to the negative x. This one will be from a to 0. And I've got the limit as a goes to negative infinity plus the limit as b goes to infinity of the integral of negative e to the negative x from 0 to b. And I'm approaching a point where I can actually take a limit, but I'm not there yet. So as a goes to negative infinity, anything to the 0 power is 1, so this will be negative 1 plus e to the negative a plus the limit as b goes to infinity. This will be negative e to the negative b plus 1. How is this going to work? Well, in the denominator, this part, e to the negative a, this will become e to the infinity power, which is just growing without bound. We take the limit, so this limit diverges, so the entire thing diverges. And it would have been fair to suspect that based on the graph, but you'd be surprised at the things that do converge that look similar. So something whose graph looks like this, you'd be surprised.